So question number 2 asks us to determine if the following lines are parallel, perpendicular, or neither. Well, we know that if we know the slope of a line, if it has a slope that is the same as another line, then those two lines are parallel. If the slope of the first line is the negative reciprocal of the slope of the second line, then it's perpendicular. But here, we aren't given the slopes, we're given the equations of the lines, and these are the lines that are the special cases. So the easiest way to answer a question like this is to actually do just a really quick sketch if you're confused. So if we've got our x and our y-axis like this, the first equation in the special case says that y equals 5. So no matter what x is, y is 5. 1, 2, 3, 4, 5. Okay, so if x is 1, y is 5. If x is 2, y is 5. So it looks like that. All right, so there's y equals 5. Now the second line says y equals 2. So I'm going to graph it. If y equals 2, I'm going to go up here to 2. No matter what x is, y is 2. So I'm going to graph that line, y equals 2. So now that we have a sketch of it, it's easy to see, oh, those two lines are parallel. So we can write that in, parallel. Okay, now let's look at the next example. Y equals 5, x equals 1. So again, just draw a sketch. Here's my y-axis, here's my, well, that's a little bit slanted. Here's my x-axis. All right, so y equals 5. So no matter what x is, y is going to be 5. So I'm going to draw it up here, just a sketch. Y equals 5. And then we have x equals 1. So no matter what y is, no matter how high I go up or how far down I go, x is 1. So when I've sketched those two lines, I can see that they are at a right angle to each other. They're perpendicular. So I'm going to write perpendicular. All right. Now, let's see. I think really all of them from here on in, you can do the same way. If you do a quick sketch, you're going to be able to tell if they're parallel, perpendicular, or neither. Just sketch them. So you can check your answers with the solutions that are provided to help you with the rest of those questions. All right, question number 3 down here. It says, the line that passes through the point A, 1 and negative 4, and is parallel to the line has a slope of negative 4 over 3. So you are supposed to graph the following lines. So I'm going to draw a line, graph a line. So what did they give me? What's some information that they gave me that I need? I know that this line I'm going to graph passes through 1 and negative 4. That point is on the line. So I'm going to go to 1 and I'm going to go to negative 4. Okay, now my line could be like this. My line might be like this. I just know that whatever line I'm drawing, it goes through that point because they told me that in the question. So I've got to keep getting some more information to know what the line looks like. It says the line is going to be parallel to the line that has a slope of negative 4 over 3. So I've got another line that has a slope of negative 4 over 3, but it's parallel to the line I'm drawing. If two lines are parallel, they have the same slope. So the other line has a slope of negative 4 over 3, but because it's parallel, so does the line that I want. It has a slope of negative 4 over 3. So I can start at this point of 1 and negative 4 and use my slope. My rise is negative 4. My run is 3. So I'm going to go down 4, 1, 2, 3, 4, and over 3. And go down 4 and go over 3. All right, so I've got my points drawn there. I can draw a line to connect them. I'm going just change the color there and draw an arrow at either end. And I have the line that I was supposed to draw. Now in question B, we're supposed to draw a line that passes through the point B, 4 and 8, and is perpendicular to the line that has a slope of 3. So once again, I'm going to start with the point that I know. It goes through 4 and 8. So here's 4 and 8 right here. So there's point B at 4 and 8. Now, my line is going through that point. It might look like this. It might look like that. Like that. I don't really know I don't really know at this point what it looks like. Okay, so I have to get some more information. All I know is it goes through that point. Okay, my line is going to be perpendicular to a line that has a slope of 3. So the other line has a slope of 3, or 3 over 1. Well, what do we know about perpendicular lines? What did we learn today? Perpendicular lines have slopes that are negative reciprocals. So we're going to flip it and multiply by -1. So the line I'm looking at, if it's going to be perpendicular to this other line, it must have a slope of -1 over 3. So I can start at 4 and 8 and count down 1 and over 3. Down 1, 1, 2, 3. And then I'm going to go down 1 and over 1, 2, 3. And I can draw a line and connect them. Perfect. Draw arrows on either end. All right, question number 4. So question 4 says, algebraically, or determine whether or not the following sets of points form right triangles. Justify your answers algebraically. So we have 3 points here, and they want us to tell us if those points will make a right triangle. Okay, what do we know about right triangles? Well, right triangles are shapes that have 3 sides, that's a triangle, and they have a right angle inside of them. So that's a right angle triangle. This one here is not a right angle triangle because it doesn't have a right angle. So we need to find out if we have a right angle. Well, what do we know about right angles like this? Well, from what we learned today, right angles are formed from lines that have slopes that are negative reciprocals. So we need to find the slopes of that line, and that line. If we know the slope of each of the lines, then if we find that 2 of the lines have slopes that are negative reciprocals, we know that we're creating a right angle. So let's back up and look at the information that we're given. All right, we're told that we have the points 1 and 3, B is at 5 and 1, and C is at 6 and 3. So I often like to do a really quick sketch so I can make sense of what's going on. So here's my y-axis, here's my x-axis, and I'm going to start with A, which is at 1 and 3. So here's 1 and here's 3. So there's A. All right, B is at 5 and 1. So I'm going to go over 5, 1, 2, 3, 4, 5, and I'm going to go up 1. So that's where B is. And then C is at 6 and 3. So I'm going to go over 6 and up 3. 1, 2, 3, 4, 5, 6, and up 3 right there. All right. So those are the points that I have. If I join them, I get a triangle. But the question is this a right angle triangle or not? So we have an idea by looking at the sketch that we've done, but it says we have to prove it algebraically. So if we find the slope of AB right here, and if we find the slope of BC, and if we find the slope of AC, we can see if any of the slopes are negative reciprocals, and if they are, they're creating a right angle. So that's where we're going to do some of our algebra. So first of all, the formula for finding the slope of a line is this. Slope equals y2 minus y1. That gives you the rise over x2 minus x1, the run that's created by the 2 points. So if I'm going to use, let's start with a and b, my first 2 points. I'm going to call that x1 and y1, and I'm going to call that x2 and y2. So y2 minus y1 would give me 1 minus 3, 1 minus 3, over x2 minus x1, 5 minus 1. So I'm going to get negative 2 over 4, which is negative 1/2. Okay, if I get a slope that's just 2, I know I've got 2 slopes that are negative reciprocals, because 2 is negative 1 over 2 flipped and multiplied by negative 1. So let's keep going here. All right, now I'm going to find the slope of the line between, I just did between A and B, so let's do between B and C. The slope between B and C. So this is going to be my x1, y1 point. This will be my x2, y2 point. So y2 minus y1 over x2 minus x1. I'm going to find out the slope using the formula. So y2 is 3 minus y1 is 1. x2 is 6 minus x1 is 5. 3 minus 1 is 2. 6 minus 5 is 1. 2 divided by 1 is 2. So actually, I can stop right here. I don't even have to go any further, because I can see that I have a slope of 1/2 with AB. So this right here has a slope of 1/2. And then I have a slope of 2 made by BC. So this has a slope of 2. Those two lines have slopes that are negative reciprocals, so they're making a right angle, and that gives us a right-angled triangle. So I can say we have a right-angled triangle because the slope of AB is perpendicular. This is the symbol for perpendicular. Is perpendicular to the slope of BC. All right, and those are the only things you needed to find for that question.